Hi guys, I wanted to make a little video for you about this worksheet. So the first page of it, you only have to do the ones that are circled. The first page of it, you're trying to find the derivative by using the definition of derivative, the one with the h. So here they're giving you an x value to plug in, so you kind of have two choices. You can do it the way that we did the other day where you leave it in terms of x and then you just plug in the x value when you're totally done, or you can just plug in the x value from the beginning. I'll do it both ways so you can kind of see. And then the next page of the worksheet is just using the alternate definition of derivative, the one with the a. So sometimes this one's a little bit more annoying, but sometimes it's easier. So I'll do an example with that kind too. And then the last page of this, so the top, they're trying to get you to write the equation of a tangent line, kind of like we did on our concept check last Wednesday. And then the bottom section is just trying to get you to write the equation of the line perpendicular to the tangent line. So if you remember, lines that are perpendicular have opposite reciprocal slopes. So for example, you kind of just do it the way that you normally do it for a tangent line, but then let's say the slope comes out to be 2/3 for the tangent line. Then just make the slope -3/2 and use the same point. So we'll do one like that too. All right. So I'm gonna do number 1 on the front page. I know it's not circled, but I kind of thought maybe it would be a good idea to do one that's not circled, and then you guys could practice the ones that are circled. Okay, so here, this is our equation, this is our x value. So we're gonna take the limit as h approaches 0 of f of x plus h minus f of x all over h. So I'm gonna plug like that into this function. I think that first I'll do it leaving it just in terms of x. So we would have the limit as h approaches 0 of 1 over x plus h minus 1 over x all over h. So now let's find a common denominator. So I'm going to multiply this by x over x and this by x plus h over x plus h. So now I will have this common denominator of x times x plus h there. And then I'm gonna figure out what's gonna be in the numerator. So I have x minus h. So that leaves me with just a negative h. And then instead of dividing by this h here, I'm just going to flip and multiply. So multiply by 1 over h, and then those h's will cancel. Then you're gonna be left with a limit as h approaches 0 of -1 over x times x plus h. And now remember that you've simplified, so now we're just going to take the limit as h approaches 0 by plugging 0 in for h, and then you get -1 over x squared. So that's the derivative. And then here they just want us to plug in 2, so you get -1/4. So this process is honestly totally the same if you just plugged the 2 in from the beginning. So I'm just going to do it real quick though, just so that you have, you kind of can see both, see which way you like to do it better. So then here I would have had 1 over 2 plus h minus 1 over 2 when I had plugged the x value in all over h. And then you still do the same thing. You multiply by 2 over 2 and 2 plus h over 2 plus h. And then it's all over h. And I still would have gotten 2 minus h. So you still would have gotten negative h over 2 times 2 plus h. And then just like we did the other one, let's flip and multiply. The h's cancel and you're left with -1 over 2 times 2 plus h. And then you just plug 0 in for h and you get -1/4, just like we did over there. So that's how you do the ones on the front page. Now let's do the same idea, but let's do it with the other definition. So I'm just going to use the same function because it's kind of similar to the one that you were assigned. This way you can kind of get a feel for it without me doing the actual problem. I don't want to waste all your practice ones. Okay, so the other definition is you're taking a limit as x approaches a of f of x minus f of a over x minus a. So let's plug this one in. So f of x is 1 over x, f of a is 1 over a, all over x minus a, and we're taking this limit as x approaches a. So once again here, you're gonna find a common denominator. So I'm gonna multiply by a over a and x over x. And then I end up in my denominator here, my common denominator is x times a, and I have a minus x. And that's all over x minus a. But instead of dividing, I'm just gonna flip and multiply now. So now we have to try to cancel something. So I think we talked about in class about how x minus a and a minus x are really just opposites of each other, meaning that a minus x is just -1 times x minus a. So when you like have a situation like this, you can just like cancel them, and it leaves you with a factor of -1. So this is really the limit as x approaches a of -1 over xa. So now we would just plug in a for x, and you end up with -1 over a squared. And then here we want to plug 2 in for that a, so that comes out to be -1/4. So that's the other process. So now let's kind of do one from the back. So the process for, not the back, I'm sorry, this third page, the tangent line page. So let's talk about like the procedure for them. So here you're literally doing the same thing as that. So actually number 9 is this example. So you already like did the work for it. You already found the slope. We know that the slope is -1/4, and we know that the x value is 2. So kind of ask yourself again, like what 2 things do you need to write the equation of the tangent line? And it's always the same thing. It's always that you need the point and that you need the slope. So we can find the point just by plugging the x value in. So we get 2, 1/2. And we find the slope by doing that whole process, which we already did. And so that was just -1/4. So now it's just a matter of kind of putting everything together. So in general, the equation of a line that we're going to be using is point slope form. So we're still going to be doing that. So we just plop everybody into place. Y minus 1/2, because that's the y value, equals the slope, the value of the derivative, times x minus the x value. And then now let's say that we had, in like the very bottom portion of this worksheet, it asks you to like write the equation of the normal line. So a normal line is just the line that's perpendicular to the tangent line. So this would be the tangent line. So if you were doing the normal line, you would do that whole procedure exactly the same. And then at the very end, you just take the opposite reciprocal of the slope. So here you would have like y minus 1/2 equals the opposite reciprocal of -1/4 is 4 times x minus 2. So this would be the normal line. Now I know the examples are a bit different on, you know, like what the actual equation is a bit different on the worksheet, but the procedure is the same. So as you're going through the worksheet and you have like specific questions about certain problems, please send a message on GroupMe, and then we can, you know, I'll help troubleshoot, you know, with that, or I can even make a little video about each, you know, the examples that you're having trouble with. Okay, have a good day. Bye.